In the understanding of black holes, there is a cardinal mistake of science that now is about 100 years that we don't understand what is happening inside event horizon. So a Schwarzschild radius, okay, 2gm divided by c squared, mass, gravitational constant, speed of light. What is the meaning of this formula? The meaning of this formula is that if a given physical object, or let's say stellar object, much better, is squeezed accordingly to this formula, the gravity on the surface of this object will be so strong that even light will not escape. Okay, this is so-called event horizon. Yeah, and because of the geometrization of gravity, the idea was that the black hole is bending, is curving space towards the center. Yeah. So there is a huge curvature towards the center. And because of this, in physics now, for 100 years, there is idea that the black hole is something special, where when you go inside, gravity is increasing. Nobody ever measured this. And when we do calculations in astronomy about, let's say, rotations of the star around the supermassive black holes and so on, we always use, when we calculate gravitational force, we always use mass of the SMBH, and on the basis of this mass, we are calculating gravity. Yeah. A black hole is particular stellar object in two aspects. First aspect is that when the light is coming closer to the black hole, it will be sucked in because gravity is so strong. Yeah. And then the Schwarzschild matrix is telling us that the black hole has a tendency to become smaller and smaller and smaller. So finally to disappear from the visible universe. What this mathematics is telling us? That black hole is eating itself. because the mass of the black hole cannot just disappear somewhere, you know. Mass is energy, and energy cannot be created and cannot be destroyed. So here, we say here we have how gravity is behaving around and inside a given stellar object. Here is the center of the stellar object, where the gravity is 0. Then gravity is increasing, is strongest on the surface, and then with the distance, gravity slowly is diminishing. We have formulas for this. We calculate this inside the Earth. We calculate the Newton shell theorem, and these are known things. The second particularity of the black hole is the idea is that the gravity in the center of the black hole tends to be infinite. This is wrong. Okay, this is completely wrong. Because also Newton's shell theorem is also valid for the black hole. And going inside to the center of the black hole, the gravity is diminishing. Yeah. What is particular in the center of the black hole, that the density of space, the energy density of space, becomes so low that atoms become unstable. This is the main physical property of a black hole that still in physics today is not understood. Yeah? So we have a black hole and inside, in the center of the black hole, atoms become unstable and they fall apart into elementary particles. Okay? Because of this, in the center of the black hole, there is immense pressure. And when this pressure becomes stronger than is the gravity force, then a black hole will explode in the supernova. Okay? Boom, supernova. If a black hole is too big to explode because there's too much matter, okay? This is characteristic for supermassive black holes, which we know they have such a shape, supermassive black holes, because most of them rotates very fast, and when you rotate, you know, you get more more flat. So what is happening here? Also here, in the supermassive black holes, we have enormous pressure in the center of the supermassive black hole. And this pressure is destroying the structure of the supermassive black hole here and here in the axis of rotation. Because in the axis of rotation, the material to be broken is much less than here. So what happens? That the black hole, you can see these very beautiful pictures from the universe. Where the black hole here is empty. There is space here. There is nothing. It's here because it's open. Black hole open, and is throwing out these huge jets. Yeah, because supermassive black hole is eating this part. Okay, this part is eaten. Energy density of space here is so low that atoms are falling apart, and boom, these huge jets. Now, regarding the idea that that the gravity tends to be infinite inside the black holes, inside of SMBH. And Milky Way, the center of our Milky Way, it's a supermassive black hole, Sagittarius A, with a small star. Yeah. Okay. Now, if gravity in the center of Sagittarius would tend to infinite, then a Milky Way could not exist. I hope you understand this. I hope everybody understands this, which is graduated in physics. If you don't understand this, then you should change your profession. You should do something else. We know that gravity force is diminishing with the distance on square. Okay? Yeah. See here? Distance on square. Okay? Now you imagine that inside the black hole of our galaxy, Sagittarius, there is gravity is close to the infinite, according to Professor Roger Penrose. Now, going away from the center, gravity is diminishing, definitely with the distance on square. But having such a strong gravity in the center of our galaxy, the architecture of the galaxy, of the Milky Way as it is, could not exist. This is irrefutable proof that Professor Penrose's idea of infinite gravity inside the black hole is wrong. So I think I'll write an article on this subject in a few days. And we will see then how open our editors and reviewers of scientific journals, I think would be the best to send this article to physical review letters, because Professor Penrose's article, I think, was published back in 64 or 65 on the subject of infinite gravity of inside of black holes. So I wish you good evening. And if you enjoy this challenge of gravity inside black holes, then you can read two articles that we published, one I think last year, one this year, and everything is calculated there, and I will be most happy if you give feedback. So good evening, everybody.